Hi friends, welcome back. Today we are going to solve another very popular and important coding interview question related to the binary trees. This is a Facebook Google coding interview question. It's on Leetcode 987, vertical order traversal of a binary tree. So as you can see from like dislike ratio, this is quite likable and popular coding interview problem related to the binary trees. This problem is of a hard complexity. So we are going to go through this problem. We are going to understand this problem today, and we are also going to understand the logic and the Java solution to solve this coding interview problem. If you are a fresher, junior level developer, mid-level developer planning to take any coding rounds of interviews, make sure you watch this video until the end so you completely understand this important problem and its Java solution code. So let's start. Given the root of a binary tree, calculate the vertical order traversal of the binary tree. For each node at position row comma column, its left and right children will be at position row plus 1, column minus 1 and row plus 1, column plus 1 respectively. The root of the tree is at 0, 0. The vertical order traversal of a binary tree is a list of top to bottom orderings for each column index, starting from the leftmost column and ending on the rightmost column. There may be multiple nodes in the same row and same column. In such case, sort these nodes by their values. Return the vertical order traversal of a binary tree. Right, so this is what the problem statement says. They have given us one examples here. Some will go there. So this is constraint says that the number of nodes in the tree will be between 1 to 1000. So maximum 1000 nodes will be there. The node values will range between 0 to 1000 inclusive, right? So this is one example binary tree. So let's take a look at this binary tree quickly. So as you can see, they have a the root is at a 0, 0 position, right? So when you go to the left side, this one is a 1 minus 1. So it means that its level is 1, right? Level is 1 and its vertical order is minus 1 basically, right? Here if you go to left for 4, the level is 2 of this node and its vertical order is minus 2, right? So like this. So this is what we want to output here. So you will start with leftmost node, which is 4, right? Then next is 2, right? Now here the interesting thing is, if you draw a line like vertical line, then you will see 1, 6 and 5 is on the same line basically, right? If you draw a vertical line, they are on the same line, 1, 6 and 5. So in this case you have to sort them basically, 1, 5, 6, right? So you have to sort them. That's what they are saying, right? So after that 3 will come and after that 7 will come, right? So if you draw vertical lines, right, on this tree basically, correct? So this is what the problem says, correct? So here is another example of the binary tree, right? So for example, if you, so what they are saying is, if you have a vertical lines like these 3 nodes will be on the same line basically. I'm showing you different because so that you can see it, but they are considered to be on the same vertical line, right? This is another vertical line. So these are the vertical lines basically, and what they are saying is we want to go from left to right. So first you will output 20 here, right? 20 you will first output, right? So first your output will be 20, then your next output will be 10, right? Vertical level, right? The next output, now you have 3 nodes on this level, right? These are the 3 nodes you will have, 50, 84, 88. So you have to sort them. So 50, 84, 88 like this, right? You have to sort them because any values will appear anywhere there, right? So like this. So 88, right? So three nodes here. After that 8 will be the next node and last node is 16, right? So this will be your output of vertical order traversal, right? So I hope you understood this now. So this is what the vertical order traversal means. So you are like drawing an imaginary vertical line on this binary tree like this basically, right? And then you will start going from the leftmost node. So leftmost node here is this, right? So this is where you will start actually. Okay, so this is what the problem says. So this is a Facebook Google coding interview question. So return the vertical order traversal of binary tree. right? So as we were seeing this is how you will return it actually. So the function, the method returns list of integers, right? So this is a list, and again it will contain list of integers, right? Because you will have you can have more than one nodes, right, in that vertical level. So 4 is this vertical level, then 2, then 1 5 6 is another vertical level, correct? If you draw a line, then 3 is another vertical level, and 7 is the last vertical level. So this is what they want us to um, find out basically, and return the vertical order traversal. So I hope now you understood this problem clearly what they are saying, right? So it may be possible that here instead of 3 nodes you may have only one node 84 here. So you have to account for that, right? So to solve this problem you need to know two things here, right? So you need to know for each node what is its vertical level. That is one thing you need to know, and you need to know what is its horizontal level also. For example, the vertical and horizontal level for 50 is 0 0. This is where we start actually. So 0 0 is this level. Okay, when you go to left, your vertical level decreases by 1, right? So let's write down the vertical level first, right? There, that's what they have wrote, right? So vertical level we'll write down next. Okay, so we'll write down horizontal level is what, 1, right? So if you, this is horizontal level, right? This is horizontal level. Okay, so this is horizontal level, this is 0, this is 1, this is 2. So horizontal lines if you draw, that is a horizontal level which starts at 0. So for 10 the horizontal level is 1, its vertical level is 0 minus 1. So you are going to left, so you will subtract 1 basically. So you are, it's minus 1. Here for 20 it will become 2 and minus 2. So I hope you are following it, right? So you are subtracting from this. When you go to left you are subtracting, when you go to right you are, for 84, right, for 84 your level will be um, horizontal level is 2 and your vertical level is 0, right? So how we got 0? You added 1 into this, right? You added 1 into this because you are going right actually. From this node, you are going right. So you added 1 into this. That's how you got 0, right? For this one, so now you can go to 8, right? So when you are going to right, your horizontal level is 1 for this, and vertical level will increase by 1. So it will become 1 here, right? 0 plus 1 is 1. So this is your vertical level. Okay, vertical level. For 88, what is your horizontal level? 2. What is your vertical level? This 1 minus 1, right? Minus 1. Left means minus 1. So 1 minus 1 is 0, right? 1 minus 1 is 0. What is your, for 16, what is your horizontal is 2 and vertical is 1 plus 1. So 1 plus 1 is 2. When you go right, it will be plus 1, right? Vertical level will be increased by 1, right? So these are your horizontal and vertical levels for each node in this tree, correct? Now if you know these vertical and horizontal levels, then you can easily create a tree map basically. So tree map is, we will use tree map here. So it will hold integer comma link hash map, right? Integer and list of integer. This is the value. So for example, so we'll start here, right? So minus 2 is your let's say minus 2 is your vertical level. So if you draw the lines here, then this is the minus 2 line basically, correct? This is minus 2 minus 1, this is 0, this is 1, and this is 2. Okay, so I'll just write down so you understand this clearly. So this one is your minus 2 vertical, minus 1 vertical, 0 vertical, 1 vertical, and 2 vertical. Okay, clear? So I'll remove this now. Okay, so now we are here. Okay, so when we are at minus 2, you are saying that which nodes are there. So in this minus 2 you have a 20 node, right? 20 node. And what is its horizontal level? Its horizontal level is 2. So you marked horizontal level, and how many nodes are there you marked here, correct? So this is the tree map basically that I am showing you, right? For minus 1, so for minus 1 means for this node you have node 10 which is at level, horizontal level 1, right? Okay, now this is more interesting. When you are at level 0, you have three nodes actually at level 0. These are your three nodes at level 0 vertically, right? Vertically, if you draw vertical line, these are the three nodes you will see. Okay, so what are those three nodes now? Which is the 50 is occurring at uh, horizontal level 0. 84 and 88 are occurring on horizontal level 2, right? So that's why it is a linked hash map of integer and least of integer. So this is the key. So key is the horizontal level, right? 0 horizontal level 0 horizontal level 2, and this value is the node values 84, 88. These two nodes appear on horizontal level 2, right? This node appears on horizontal level 0, right? So this is how we will prepare this tree map. Okay, so now I hope you are following this clearly now with this explanation. Now you will go to the next node, which is 8. Now what is its vertical level is 1, right? So that is the key, and um, sorry, this is the key here, and its value is 8, right? And its horizontal level is 8, right? Like this. Then this is the last node, 16, right? This is vertical level is 2, horizontal level is 2 for the same, and its value is 16, right? So we have created a map, right? A tree map. Once you have the tree map, you will start just going through this tree map values from top to bottom. So tree map will keep the keys in sorted order. That's why we are using tree map, right? Tree map keeps the keys in sorted order. So because that's what we want actually. Once first we want -2, then we want -1, then 0, then 1, and then 2, right? This is what we want in our output, correct? So that's why we are going to use tree map here. Okay, so I hope it is clear to you now how we are going to solve this problem. So if you take a look at this example that we were looking at, then you will just use the tree map that you created. You just go from left side, then you will get 4 first, then you will get 2. For the next level, you will get 1, 5, 6, right? So you will get 1, 6, 5, and you have to sort it basically, because there are multiple values. Whenever there are multiple values, you have to sort those values, right? Then you will get 3, and then you will get 7, correct? Because it's a tree map, right? Like this. So this is how the tree map will look like, and these values, these keys are in sorted order. So -2 first, then -1, then 0, then 1, and then 2, right? Okay, so I hope now it is very clear for you how the vertical order traversal works for a binary tree. So let's go ahead through the code step by step so you understand how to write a code for the same approach that we just discussed. So first we are going to create one class. We'll call it as a node. It will hold tree node object. Tree node is a node object of a binary tree. So this is a tree node actually, right? And it will have this tree node is here, right? So tree node is given to us. So this is how tree node look like. So it will have value. It has left and right tree node childs, right? And x and y is these are the vertical and horizontal level, right, of the node. We have to maintain two things of always for every node there, its vertical position and its horizontal position, right? Two things we will need. Okay, so vertical traversal is the method we are implementing. A root of the binary tree is given to us. It returns list of integers, right? So we are first going to create a tree map. So tree map is going to hold integer, which is the vertical order, right? -2, -1, 0, 1, 2, those things, right? That we have seen here. So that is the key, and the value is a linked hash map of integer comma list of integer, right? So here the linked hash map will hold integer, which is the horizontal order, right? So horizontal order, for example, horizontal order for this node is 2. Horizontal level, basically, not order, horizontal level is 2 here. Horizontal level for 50 is 0. Horizontal level for 84 and 88 is 2. And then this is the list, means what are the nodes which are on that level 2. These are the nodes, and these are the level 0 and level 2, right? vertical level 0, horizontal level 2, for example, right? Okay, now this is our root node. So root node is the actually will start with root, and 0 0 is its position, right? 0 0 is the position of a root node, as you can see here. So now we are going to use a BFS here, right? So BFS will need a queue, right? So we'll create a queue of node objects. So these are our nodes that we have created, right? So now here let's take a look. So in the node here, right? So we'll start adding the root node that we created here, right? So the root node is created. We'll start it because the BFS queue need to have something in it to start the BFS, right? So that we can start the BFS. So we'll add root node. And this while loop is a typical BFS implementation where our BFS now start. So you remove the current node from the queue, which is your root, right? And you actually create a linked hash map of integer comma list of integer, right? And map.compute if absent. So current.x, and this is a lambda expression, right? K is new linked hash map. So it is saying that if it is absent, then you have to create a new linked hash map. If it is, so this one will only create if it is absent, like first time, right? First time when it's not there. Okay, so because first time it will not be there, so it will create it, otherwise it will not create it. After that you will use this vertical, and you will again use compute if absent y, right? Current.y. Here you will add the array list if it is absent for that level, correct? For that level, so you will get the linked list of integers for that level, correct? Because every level can have multiple nodes, that's why you will have a list of integers. Now the current node that you removed here in the queue, you have to get the value of that node and add it into this level, right? So this level you add the current node dot value, right? Correct? Okay. And after that you will check if the current node has a left node, right? If it has a left node, you have to create another node object here, right? And add it to the queue. So when you are creating, you have to, this is the value of your left node. Current dot node dot left is your left node value, right? Means left node. And then you have to have current dot x minus 1 because you are going to the left, right? So your vertical level will decrease by 1. You are going to the left, your vertical level, x is vertical level, it is decreasing by 1. Whenever you are going to a child, your um, horizontal level always increase by 1, right? So horizontal level is increased by 1. Okay, so y plus 1. So here also horizontal level will increase. For right child also it will increase the horizontal level, but your vertical level will increase for right child because you are going to the right, right? So this is 0, your um, vertical level. So now it became 1 because it increased by 1 here, right? It increases here, it will be reduced by 1, so it will become minus 1, minus 1, again minus 1, it becomes minus 2. Left means you will subtract minus 1, right side means you will add add a 1 basically, right? So that's what, and you will add it into the queue. So this way it will loop and it will perform BFS and it will populate the map, correct? So it will populate this map that we have created here, right? This map of which is a tree map, right? So now once we have the tree map populated and ready, now we have to create the output list, right? This is the output list that we have to create from that tree map, right? Which is list of integer. We'll call it as a result, which is array list. We will go through map.values. So map.values will give us the linked hash map, right? Nodes, which is integer and list of integers, vertical nodes, let's call it vertical nodes. Okay, so it means that we created, let me remove this. So we have this we have this tree map ready now, right? We have created this tree map. Now we have to go through each of these values. So for first value minus 2, you will read this value, right? Which is 2 and 20. That's what you get here, right? That's what you get here, 2 and 20. So 2 is your integer key and the 20 is your list actually. It is list of integers, right? This is a list of integer. 20 is a list of integer. For example, in this case, for value 2 your list is 84 and 88, right? So you can have multiple values there. That's why it is list of integers. So you create one list of integer here and you go through your vertical nodes dot values. So this is the vertical nodes, which is a linked hash map, and its values are again a list of integers, right? So this is a little bit complicated, but it's pretty simple once you understand it, right? So it gives you list of integers. For each level you will get list, right? For example, here for 0 level you have list which has 50. For level 2 you have 84 and 88, correct? For horizontal level 2. So this is your horizontal level 0, this is your horizontal level 2, right? You get two things here. So you have to sort these levels basically and add it to this list, right? Because if you have multiple numbers there, you have to sort it. That's what they said in the problem. So I'll show you that quickly here. So there may be multiple nodes in the same row and same column. In such case, sort these nodes by their values, right? That's why we have to do this sorting. Okay. At the end, once your list is prepared, you have to add it to the result. Correct? You have to add that result list into the result. At the end, you will just return this result. Correct? So once you return the result, you will get a list like this basically. So first you get 4, this, then you get 2, then this is list A, this is all our list, right? 1 5 6 is another list and it is sorted. Important thing is it is sorted. Okay, then 3 is a list, then 7 is a list. So each is a list for that vertical level, right? I'll repeat it again. This each, what I'm showing you, this each is a list on for that vertical level, right? 4 is a list for -2, 2 is a list for -1, 1 5 6 is a list for level 0, 3 is a list for level 1, 7 is a list for level 2, vertical levels. Okay, so this is how we are preparing our output here. So I hope I explained you clearly. So this is how actually you can write down the code to solve this problem. So this problem was asked by Facebook and Google. So here the important thing to note is we have used tree map because we want the sorting order of the keys, and we also use the linked hash map, right? Linked hash map also we have used. Okay, so let's go ahead, test this code, make sure it gives us correct answers. So for the first example, let's go one by one. So this is the first test case. Our output and the expected output is matching, as you can see. So for the second test case, this is the second example that we are looking at now. 4 2 1 5 6 3 and 7. So 4 2 1 5 6 3 and 7. So we are getting correct answer. So this is the case 3, which is third example, where you have to do the sorting here, right? So this is the example. So again we are getting correct answer. So we are getting correct answer. Submit this code to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 79.5% faster on the performance side compared to other submissions, and 59.5% faster on the memory usage, which is pretty good solution to solve this coding problem. Facebook Google coding interview question on Leetcode 987, vertical order traversal of a binary tree. So I hope you completely understood this problem and this logic, how we have solved this problem with the help of tree map and linked hash map and this logic that we have discussed here using BFS, right? So I'm going to add this code in my GitHub repository and give you the link of this code, so you can check out this code. You can create your own custom binary trees and see how this code works correctly and do the vertical level order traversals. There are lots of other important algorithms and Java solutions which are already implemented and available there for you. Don't forget to check out the other Java codes there. They will definitely be helpful for you in your interview rounds and preparation. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, we have created a very important coding interview related playlist to help your interview rounds. The name of that playlist is Leetcode and Leetcode Solutions. We have compiled more than 250 most frequently asked very important coding interview problems for you under one playlist here. Those are the coding problems that got asked by many big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, Netflix and many others. Many times in their interviews. So those are very important coding interview problems. Make sure you go through those problems and understand the logic behind their solutions. If you go through those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques of problem solving that you can use and apply in your interview rounds. You will also learn a lot of Java coding on this channel. You will come to know about what are the frequently used Java classes and APIs that we often need during the implementation of different concepts and different solutions. So it's going to help you a lot in your interview preparation and learning process. So make sure you check out those solve coding problems. The name of the playlist here is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer, you want to practice more coding problems. To help your practicing purpose, we have created 3 other playlists on this channel for you. The names of those playlists are Code Forces, Code Chef, at Coder, Code Forces, Code Chef, at Coder, all in all. More than 800 different varieties of problems are here to help your interview preparation and learning process. If you like this video, if you find this video helpful, how we have found out the vertical traversal of a binary tree, this important Facebook and Google coding question using BFS linked hash map and tree map logic, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. So if you like this video, then do subscribe to this channel, give it a like to the video, share this video with all your friends. So your friends can also watch these videos. They can also learn problem solving, logic building, Java coding, programming using different data structures and algorithmic approaches. On this channel, you will see all important coding questions variety solved and explained here, including breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm, and many more important algorithmic problems. There are lots of important data structure questions also available here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, and many more important logical coding interview problems. So make sure you check out those other important solved coding problems as well. They are also very important ones from interview perspective and definitely help you in your interview rounds. To help freshers and junior level developers, we also have created other important videos here. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries to retrieve different information from those tables, where you may have to use different database concepts like inner join, outer join, left outer join, right outer join, aggregate operations, group by and having clauses, different where clauses. Everything is explained for you in those videos step by step with examples, so you also will be able to solve those kind of SQL programming interview questions and write down those kind of SQL queries. So make sure you check out those other SQL problems as well. They are also frequently asked questions to the freshers and junior level developers in the recent interviews. If these videos are useful and helpful for you, then write down in the comments and put it in the below description for these videos. Your feedback and comments both are highly appreciated and very valuable for us. That increases our motivation to create more quality content. So if this content is useful and helpful for you, then do mention that into the comments. Share these videos with all your friends so others can also learn by watching these videos. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process going on continuously. And thanks for watching these videos.